Hello everyone, this is Steve. Thank you for joining me. We're going to graph this rational function here. Let's get started. Well, I'll tell you, I'm looking at this thing and usually I like to try and factor the top and the bottom right when I get started, and I can see how to factor the bottom because I can pull out an x, get x squared minus 4, and then I can factor the x squared minus 4 as difference of squares, so it's x times x plus 2, x minus 2. But I actually can't see how to factor that numerator, so we'll talk a little bit more about that in a moment. First of all, let's jot down our domain. Now, we'll notice with this one, we have three numbers we have to kick out of our domain because there are three values that will make the denominator equal to 0. They are -2, 0, and 2. No common factors are going to cancel, so this particular graph is going to have three vertical asymptotes. One for each value we kicked out of the domain. So the vertical asymptotes are going to be x equals -2, x equals 0, and x equals 2. A lot of vertical asymptotes here. How about horizontal asymptotes? Well, if we have one, we find it by looking at the degree of the numerator and the degree of the denominator. So we have a degree 2 over degree 3. Now, when the degree on the bottom is larger than the degree on the top, like we have here, we have a third degree on the bottom and a second degree on top, then we do have a horizontal asymptote, but there's no math to do to find it. It's just going to be y equals 0, directly on the x-axis itself. So we actually are going to have a horizontal asymptote that's right on the x-axis and a vertical asymptote that's right on the y-axis. Okay, X-intercept. Well, the way you find an X-intercept is you would set the top equal to 0. 4x squared plus 1 equal to 0. But I notice that if I try to solve this for x, I'm going to have to take the square root of a negative number, which means the only values that make the numerator equal to 0 are imaginary numbers, which means they're not x-intercepts. So this particular rational function has no x-intercepts. Furthermore, and here's the really cool part, we actually don't have any y-intercepts either. Because the only way you can have a y-intercept is by plugging a 0 into the original function. We're not allowed to plug 0 into the original function because we already kicked 0 out of our domain. So that means we also have no y-intercept. So the only tools that we have when we're going to go to our graph here in a moment are just the asymptotes. We got to figure out where the graph is without any x-intercepts and without any y-intercept. Let's see how that goes. Okay, so I guess since I know the asymptotes, I'll put those in. So there's x equals 0. There's x equals 2. There's x equals -2. It looks like we have three vertical asymptotes, so our graph's going to have four pieces. There's going to be one over here, one in here, one here, and one over here. And I do have a horizontal asymptote also, right here. But since I have nothing to go on, I have no ordered pairs to start with, I'm going to have to actually find some ordered pairs on my own. Because if you try to just do some guess and check, it's not going to work really well because you can see if you drew this and kind of said, which one is it? Well, we really don't know because neither of them touches the x-axis or does anything illegal just by looking at the picture. So we're going to have to figure out some actual ordered pairs in the graph. So let's get rid of those because I don't know which one it is. And I brought the function down here with us so I could plug in some numbers. Now, the numbers that we're going to plug in are very important because we're going to plug in a -1 and a 1 because they both appear in between the vertical asymptotes like that. And then we're also going to plug in this -3 and we're going to plug in a 3 because they're beyond the vertical asymptotes. And just by determining where these points are, we can determine where the rest of the graph is. So what I did was I plugged in a -3, a -1, a 1, and a 3. When I plugged in -3, I actually got -37 over 15, which is approximately equal to -2.47. Which means over at -3, we're actually down below the axis. We're down here somewhere. So I know that the whole graph, or this whole piece of the graph, is going to be down here. Then when I plugged in -1, I got +5/3. which is, roughly 1.67. So therefore, I was above right here. So that means the graph is going to look something like this in here. It has to, because it can never hit the x-axis. When I plugged in positive 1, I got negative 5/3, which is approximately equal to negative 1.67, which means very similar shape, but down here instead. And then when I plugged in a 3, I got 37/15, positive this time, which once again, get an approximation there. So I have a piece up here as well. That was a little trickier because we had to plot 4 points, but 4 points is all it took, and knowing that our graphs hug the asymptotes. So I was kind of curious how close I was, so I graphed this one on a computer to see what it looked like. We did pretty well. The only 2 things I want to point out here at the very end is, first of all, please remember that even though these shapes kind of look like they are, this shape right here and this shape right here are not parabolas. The other thing is, when I just drew my rough sketch of it, I sort of assumed that the point I was finding was either the low point or the high point in here, and that's not necessarily the case. But we did get a rough sketch, so we don't have every little cell detail. You can see how these are kind of not quite symmetrical among themselves. This doesn't even look like a parabola. But our sketch was close, so we did all right. I hope that helped. Thanks for watching.